Hi, welcome to lesson 5.2. This lesson is called the Fundamental Theorem of Algebra. And in this lesson, we are going to know and apply the fundamental theorem of algebra. And we are going to write polynomial functions given their degree and roots. As a consequence of the fundamental theorem of algebra, a polynomial p of x with degree n greater than equal to 0 has exactly n linear factors, counting factors used more than once. So basically that means that if a polynomial is a cubic, like let's say in example A, where we see 3x to the third, well, you're going to have three factors, three linear factors, and then of course three roots or zeros or x-intercepts if they're real. So you can see in example A, the polynomial is a cubic, and when you get down to the factors, you will see that you have, here you go with a plus or minus I root 2, 4, that's two of the solutions, and then a negative 3 is the third. So you'll get three solutions because it's a power of 3, and some of them may not be real. So we're going to practice finding those solutions using the zero product property, which means basically we're going to use some factoring to help us solve. We may need to use some other quadratic methods as well as factoring. So let's start with the first one. In the try these A, we've got f of x equals x cubed plus 9x. We're going to start by letting the expression be equal to 0. So 0 equals x cubed plus 9x. And then we want to factor it. So there is a greatest common factor of x, so we're going to factor out x, and then we're left with x squared plus 9. So if you remember from last year, we just have to set each of those factors equal to 0 and solve. So x equals 0 means one of our solutions is going to be 0. X squared plus 9 equals 0 means we're going to have to subtract 9 on both sides, so we get x squared equals negative 9. And then if we take the square root of both sides, we actually get plus or minus, and we get 3i. So x is also equal to plus or minus 3i. So we did get the three solutions. We got 0, and we got plus or minus 3i. And a lot of times we write them in a set notation. Okay. So that was greatest common factor. In part B, we'll see a different factoring type. We should notice that x to the fourth minus 16 is a difference of squares. So when we set equal to 0, we're going to get x squared plus 4 and x squared minus 4. And those two factors set equal to 0 will get us our other two solutions. So x squared plus 4 equals 0, and x squared minus 4 equals 0. So we get x squared equals negative 4 and x squared equals positive 4. And when we take the square roots of both sides, we're actually going to get four solutions. We're going to get on one side plus or minus 2i, and on the other side plus or minus 2. So we're going to get plus or minus 2 and plus or minus 2i. When we take the square roots of negatives, remember we get i's. Okay. So we have a few more factoring types here that we'll go through. So part C is a trinomial, and it actually is one of those where we have a quantity filled in, and we could try to factor it in by using a replacement if we wanted to, or we could just try to factor it the way it looks. So we want to get two numbers that multiply to 4 and also add to 4. So we're going to have x minus 2 plus 2, and we're going to have x minus 2 plus 2. So we're going to actually get identical factors. And if we look at FOIL, we will see that this does work. X minus 2 times x minus 2 is x minus 2 quantities squared. And if we do outers, we have 2 times x minus 2. Inners are 2 times x minus 2. That's 4 times x minus 2. And 2 times 2 also equals 4. So when we simplify these, we actually get x minus 2 plus 2, which is basically just x. So we're going to get x And on the other side, we're also going to have x minus 2 plus 2, which is basically just x. So we just get x equals 0 when we solve. And that means that it looks like there's only one solution, but that just means that this one is a double root. It means that this 0 came twice. And we see double roots sometimes. And we'll see more of those in a little bit, actually. So in part D, we have x cubed minus 64. So for this problem, I see a difference of cubes. And so if you remember your cube factoring pattern, we want to take a minus b, so that's going to be x minus 4. And then we want to do x squared plus 4x plus 16. And of course, we want to set that equal to 0. Now, one of these zeros is pretty easy to find. It's going to be x minus 4 equals 0, so x equals 4. The other one, however, does not factor. And so what we're going to need to do is go in and use the quadratic formula. So I'm going to review that for you a little bit. I'm going to kind of cross off F so that I can show you some space on how to do the quadratic formula. So we need negative b, so that's negative 4, plus or minus the square root of b squared, so that's going to be 4 squared, minus 4 times a, which is 1, times c, which is 16, all over 2a, which is 2 times 1. And so when we simplify inside the radical, we're actually going to get 16 minus 64, I believe. And if we do that, 16 minus 64, we get negative 48. So I have negative 4 plus or minus the square root of negative 48 all divided by 2. And so now we can break down negative 48 and also pull out the negative as an I. And so when we break down negative 48, if we think about it, it's really 16 times 3. And so it's going to be negative 4 plus or minus 4i root 3 all over 2, which we can simplify a little bit more and divide everything by 2. So we get, we'll put our final ones up here, we get negative 2 plus or minus, and we get 2i root 3. Okay, and that along with the 4 make up our 3 solutions. Okay, so it's a little bit of work when you have to use the quadratic formula, but we can always get our solutions that way. Okay, so we'll do one more of these, which is going to be a 4-term polynomial. We actually do a little grouping on this one. So we'll set it equal to 0, of course. And if we group the first two, we can factor out x squared, and we get x plus 5. And in the second grouping, we can factor out 9, and we get x plus 5. So 0 is equal to x squared plus 9 times x plus 5. And we know from the problem above, x squared plus 9 produced 2 imaginary roots. We got plus and minus 3i. X plus 5 produced negative 5. If you set it equal to 0, you have to subtract 5 on both sides, you get negative 5. And so now we have our 3 solutions. We have negative 5 plus or minus 3i. Okay, so we just didn't get to go over F because we kind of ran out of room. So on the next page, I'm going to leave the check your understanding as part of your assignment for tonight. So you're going to be working on 1 through 4, and we'll go over those in class. Okay, so that's kind of like the first part of our lesson, and we sort of wrap it up by creating a little flow chart. So you want to make a little flow chart or some sort of organizational scheme or a set of directions for finding the zeros of polynomials. Basically, I'm just going to make a list of our 3 steps that we're going to use. So for step number 1, you're always going to want to try to factor the polynomial. Step number 2, you're going to set the factors equal to 0. Okay, and then step number 3 is solve each factor. For x using linear or quadratic methods, as you saw us do on 1. So you get a little more practice with those when you work on that check your understanding and some of the practice set that you'll see at the end. So what we're going to actually do now is work backwards, and you'll be presented with the solutions and you have to come up with the polynomial. So these range from very simple problems to pretty complex problems. And so I'm just going to pick a couple to show you how to do and save some of maybe the harder ones even to show you how to do in class. Okay, but I'm going to start with the first two in the try these here. And so in this information, they start by telling you how many zeros there are. Okay, so like in part A, it tells you there's 3 zeros. Okay, and then you can see that the zeros are 0, 5, and -7. So you want to start by taking the zeros and then creating the factors. So if a 0 is 0, then one of the factors has to be x. If a 0 is 5, well then it must have come from the factor x minus 5. And if a 0 is -7, then it must have come from x plus 7. And then of course it's an equation, so we set it equal to 0. We'll probably change that and set it equal to f of x when we're all done. Now we just have to use algebraic methods to multiply, do a little FOIL, and then distribute that x. So I'll just do the FOIL first. So x squared, and I have 7x minus 5x is 2x in the middle. -5 times 7 is -35. And then the last step, we just have to distribute the x. So we actually get x to the third plus 2x squared minus 35x. And that is our polynomial function with a degree of 3 and then 3 zeros. Now part B actually has 4 zeros, okay, but it's not too bad because you'll see when we multiply, if our factors, if our zeros are +1 and -1, that makes our factors x minus 1 and x plus 1. And then, of course, the same with plus or minus 5. One of them had to come from x minus 5, and one had to come from x plus 5. So I would just start by foiling out each of those individual pairs there, which are actually conjugates of each other. And so if we do our FOIL for the first two, we get x squared, and then 1x minus 1x is gone, and then -1 times -1 is -1. So there's our first pair, those little difference of squares there, and our second one does the same. We get 5x minus 5x, and they're gone, and minus 25. So now we just have to FOIL that out, and we should have our polynomial. So let's go ahead and put this with an f of x now. So f of x equals x squared times x squared is x to the 4th, -25x squared, and -1x squared is -26x squared. And then positive 25, and there's our polynomial. Okay, so those all had some real roots. We had 3 zeros, we had 4 zeros, but they weren't too hard to get back into the equation. Okay, so we will look at a few more challenging ones on the next page. Okay, so here we start talking about something called the complex conjugate root theorem. And basically what it says is that if a plus bi is a root and b is not equal to 0, meaning we have an imaginary. And if that's a 0 of the function, well, it has a partner. Its conjugate, a minus bi, is also a 0. So really that just means like if you're told you have a 0 of 2i, well then you automatically have another 0 of -2i. They always are going to come in pairs. Okay, now that's just for the i's. That's not for like if you have a 2, it doesn't mean you have a -2. But 2i and negative, they always come in pairs, plus or minus 2i. Okay, so they go through a couple examples for you, and those are good for you to have, but I'm just going to pick one to do in this group and maybe even a second one, we'll see. But to start with part A, in the try these, they tell us it's important to look so you can remember that if there's going to be, if it's a polynomial of degree 3, there's going to be 3 zeros. Okay, and they've given us x equals -2 and x equals 3i. Well, that means that if 3i is a root, then x equals -3i also is a root. And so we're going to need to include that when we write our equation. Okay, so now time to write the factors. So for x equals -2, well, that came from x plus 2. And then for x equals 3i, that came from x minus 3i. And for x equals -3i, that came from x plus 3i. Okay, and then, of course, we set it equal to 0, and then we'll change it to f of x. So I would suggest doing the FOIL with the conjugates first because outers and inners tend to drop away. So I'm going to keep, for right now, the x plus 2, and I'm going to FOIL out the other two. So x times x is x squared. Outers is 3ix, inners is -3ix, so they're gone. -3 times +3 is -3i times +3i is -9i squared. So that brings us back to I squared. Do not forget that I squared always gets replaced with -1. So that actually changes it to x plus 2 times x squared minus 9 times -1, which becomes plus 9. Okay, now all we have to do is FOIL that out. We'll have our equation. So I'm going to put that over here. So f of x equals x to the third. If we do first times the first, then I'm going to do the inners first so it's in order. Plus 2x squared. Then the outers plus 9x. And then the last is plus 18. And that's our polynomial function, degree 3, with those 3 zeros. Okay. And then part B is a little challenging. I'm going to leave that one off for right now and do that one in class with you because there's definitely not enough room on this page to go through that one. So for part C, however, we have this idea of the double root that I told you was going to be coming back. So I want to talk about that. So there are 4 zeros. We have 2, -5, and then it says x equals -4 is actually a double root. So when we make the factors, x plus 2 came from x minus 2. X equals -5 came from x plus 5. And x equals -4 came from x plus 4. But since it's a double root, that means there are 2 factors that produced the same root of -4. And so what we're going to do now is we have to multiply all of these out. And so I would say, let's do 2 at a time. And we'll get ourselves into 2 trinomials. Okay, so if I do the first 2, I get x squared, and then I get 3x minus 10. So there's the first one. I just did the outers and the inners together. The second one is x squared, and then it's 4x plus 4x, which is 8x, 4 times 4, which is 16. Now I'm going to need some space, so I'm going to go to the side here, and I'm going to go ahead and distribute x squared across. So I have x squared times x squared is x to the 4th, then plus 8x to the 3rd, and then plus 16x squared. I'm going to start lining things up underneath, because now I'm going to distribute the 3x. So I get 3x times x squared is 3x cubed, and then plus 24x squared, and plus 48x. Okay, and then in our last distributive, we have -10 times x squared, which is -10x squared. -10 times 8x, -80x. And -10 times 16 is -160. So now if I add up all those terms together and I set it equal to f of x, I should have it. So I'm going to have x to the 4th plus 11x cubed, okay, plus 30x squared minus 32x minus 160. And that is a polynomial with 4 zeros, one of which was a double root. Okay, so I'm going to save that part B for class. Okay, and then you get some more check your understandings to try, and there's all your lesson practice. So I'm going to be picking out some of these problems to do as notes in class on Monday and Tuesday. So we will get an opportunity to practice all the things that you saw in this video.